Okay, so I'm working problem number 4 in our packet, and this is 49 by 25. And if you look a little bit closer, oops, I've worked out the pieces. It's called a partial product. And we're starting with the 40 part times the 20. And you can think about it as 40 times 20 equals 800. Or, in the second example, I have 40 times 20 is like 4 times 2 with 2 trailing zeros, the zeros that are at the end. And I've written it as 8 with the 2 trailing zeros, or 800. That's going to help us keep track of what rod to build our number on. You'll then see that we've done 40 by 5. 40 times 5 is 200, or 4 times 5 with 1 trailing zero is 20 with an extra zero, 200. 9 times 20 is 180, or 9 times 2 with a trailing zero is 18 with a zero. And then 9 times 5, and those are our ones, and it equals 45. And that's what it would look like on paper. Now we're going to show you what it looks like on the abacus. Let me just adjust the camera a little bit. Oops. Here we go. So on our abacus, we're going to start by setting up our problem by putting the multiplicand, the first number, the thing that tells us what we have groups of. And we have groups that are 49 big. And we can build that starting at our second reference dot from the right. We're building our 49, just like that. And then our multiplier, the thing that tells us how many groups we have, the second part of our multiplication problem, we're going to put on the the first reference dot from the right, all the way at the very end. We made our 25. And so now you can read our math problem here. 49 times 25. And in order to solve it, we're going to go back to our regular center rod where we would do our normal addition and subtraction. And that's where our answer to the problem, or our product, is going to go. Product is just the word that we use for the answer to a multiplication problem. So we're going to do the partial product, the pieces that add up to our number on our abacus, and we're going to start, like we always do, working from left to right. So we're going to take our leftmost number, the number that's in our tens place, our 40, and we're going to multiply it by our 20. Again, we can think about it as 40 times 20, or if that's hard to keep track of, we can think of 4 times 2 with 2 trailing zeros. The trailing zeros are going to tell us how many places we need to move over to do our work. So 4 times 2 with 2 zeros. 2 zeros moves us over 2 places to the left, and we'll start on our hundreds rod. 40 times 20, or 4 times 2, is 800. 8 in our hundreds rod. So we can build our 8. And then we move to the second part of our problem. We've multiplied our 4 times our 20. Now we want to multiply that 4 in the tens place by the ones place in our multiplier. So 40 times 5. 40 times 5 is 200. We can count it as 40, 80, 120, 160, 200. We can multiply 4 times 5, which gives us 20. But remember that our 1 trailing zero in our problem tells us we need to move over 1 rod to our tens place, and then we could build our 20. 20 wouldn't fit on our tens rod. That's why we need to move over here. We go to add our 20, our 2. We need to use a dime exchange, and then the 0 part fits on the tens rod. We move to the next part. Oh, sorry. our 40 is now done. We've multiplied the 40 by 20 and the 40 by 5, so we can actually clear that from our abacus to help us keep track of what part we've used already. And now we're going to multiply the second part of our multiplicand, our ones place, by both pieces of the multiplier. So we're going to take 9 and we're going to multiply our 9 by 20. 9 by 20, we can think about it as 9 by 20 is 180, or 9 times 2 is 18 with 1 trailing 0, and we can go ahead and build our number. If we're thinking about it as 180, we just find our hundreds rod and build our number. If we're thinking of it as 9 times 2 with 1 trailing 0, we find our ones place, we move over a rod, and then we build our 18. And of course, if we're building 18, it's a 2-digit number, so we're using 2 rods, making sure that our 8 is on that rod, our starting rod. So our abacus now reads 1,180. We're almost done with our problem. We've used our 9 times our 20. Our 20 has now been multiplied by both parts of our multiplicand, so we can clear that. And we're now just left multiplying out the ones. We've got our 9 from our multiplicand and our 5 from our multiplier. We can multiply those together, 9 times 5. And because there are no trailing zeros, we know it's going to go on our ones place. So we go to our ones place and we want to make our 45. 40 doesn't fit, so we need to move it over. We actually need to use a dime exchange to do it. So 40 and then our 5. And we now have our answer, 1,225, which matches our earlier work, pencil and paper work. That's our process. We talked in class the other day about why this works and how 49 times 25 is kind of like having a group of 40 and 9 blocks and a group of 20 and 5 blocks. And this is not to scale, unfortunately. And so we're picturing all of those little tiny blocks, 40 rows this way, 20 rows that way, and over here we have another rectangle. This one is 9 by 20, so you could picture 9 rows of 20 blocks here. And that's where we get our partial products from. So this was a lot of new information, especially for our students who multiplication hasn't been taught in school yet. Tried to provide a visual way using the geometry and then really spelling out those partial products. We have our tens place shortcut using those trailing zeros, or if you have the number sense to do a 40 times a 20 and understand that that's 4 tens times 2 tens equals 800. That's another strategy. We'll be working with these more from week to week. If you have more questions about this as you work through the homework, feel free to email and I will try to respond as quickly as I can. If you'd like, we could do one last problem. This is going to be problem number 5, and problem number 5 in our packet reads 52 by 35. Again, I'm going to set up my multiplicand, the first part, on my abacus by that second reference dot. My 35 is going to go at that first reference dot, and we can actually read our problem on the abacus now. 52 times 35, and this is where we start solving. We're going to take our tens place and multiply it by the tens place in our multiplier. I'll label those multiplicand, multiplier. And I'm going to use the trailing zeros to talk through this example. So 52 times 35, 50 times 30, 50 times 30 would have 2 trailing zeros. So I'm going to start here. I'm going to move over 2 rods, and I'm now at my hundreds rod, and I'm going to make my 5 times 3, 15. So my 15, my 5 is going to be on my ones place, my 10 is a spot over. I called it my ones place, but actually since we moved over, it's the hundreds place. So 50 times 30 is 1500, or 1500. Now I multiplied my 50 times my 30, that piece is done, but my 50 still needs to be multiplied by the 5 in my multiplier. 50 times 5, 50 times 5 has just 1 trailing zero, so I'm going to move over here, step over just 1 rod. 5 times 5 is 25. I'm going to build my 25. And now my 50 has been multiplied by both pieces of my multiplier. I can clear it away from my abacus so that I know that it's done. I've already multiplied those pieces out. And so now I'm just left with 2 times 35. I'm going to multiply my 2 times my 30, my tens place. 2 times 30 has 1 trailing zero. So I'm not going to start on the ones, I'm going to start 1 rod over to the left, and so 2 times 3 is 6. I need to do a NIME exchange in order to add that 6, but that piece is now done. My 30 has been multiplied by the 50 and the 2, so I'm going to clear that, and I'm left with the last piece of my multiplication problem, 2 times 5. 2 times 5 doesn't have any trailing zeros. It's both ones, so we know that it's going to go on our ones place. 2 times 5 is 10. I go to make my number, 10, just like that. And now I can read my answer. My answer is 1820. 1820. And that's how it's done. Thank you.